that and then okay, all right. So today's lesson is gonna remember how last week we didn't finish everything that we wanted to cover? Well, we're just gonna finish that stuff today, and then we're gonna introduce you guys to another concept called inheritance, which has a lot to do with classes. So yeah, I guess. All right. So the first thing is the concept of null. All right. And objects can be null when basically what null means is that they contain nothing. All right. And it's different from zero, which is still a number, but null just means like it's just blank. There's just nothing inside of it. And an example of how to set them as null is like this. All right. So you just put whatever object you want to set to null. In this case, we're actually creating an object called O of the object class, and we're going to set it equal to null. And O just has nothing inside of it. And it doesn't always have to be from the superclass of all the objects. It could be any object, including strings. It could be an object of a class you created, in a pre-made class, whatever. It can be anything. All right. And if you try to access something inside of a null object or an object that is null, then you will get a runtime error. So the code that you wrote is compiled, but when you actually try to execute it, you get an error. All right. And what that error is called, it's called null pointer exception. And it's an exception that occurs when a variable or a method of a null object has been attempted to be accessed. Right? And quick little review, just like all other exceptions, you can purposely cause it in your program. And the syntax for that would just be throw, new, and the exception name. And then in parentheses after the exception name, you can put a message that you want to print out along with the exception error. And this is sort of important, but you can't set primitive data types to null. Null can only be set to objects. Okay. So that's basically it on null. Just something that represents nothing, and you can only set it to objects. All right, so we're going to go to the next part of this lesson, which is get and set methods. All right. So remember, every time we wanted you guys, or every time you guys created instance variables in a class, we always wanted you to make them private. All right, but a problem with private variables is that it doesn't allow users to directly access them. All right, so we can't just say, let's say we create an object. Object has the class as a private variable inside of it. We create an object of that class. But when we try to access that private variable, we can't access it because private is only limited to the class it was created in. Not even the objects can access it. Well, to fix that, we can implement get and set methods to be able to handle them. And to implement them, we just create a method in the class that returns or sets a private variable, hence the name get and set. All right. And with get methods, other members of a program can access those private variables, and with set methods, others can modify them. All right, so let's say we have one class, all right, class called A, and a class called B. Well, obviously, since the instance variables are private, a private variable in class A cannot be seen by something in class B. Well, if we want class B in order to be able to access those private variables, then we would need to use get methods. And let's say you wanted class B to change or modify those private instance variables, then we would use set methods. All right. So sort of like a fancy name for get and set methods is that a get method is also called an accessor method, and a set method is also called a mutator method. Okay. And so usually the standard form, wait, hold on a second. Actually, it's okay. Well, usually the standard form of a get method is that you just call that method and then you return the private variable. And for set methods, you just pass in a parameter that you want the private instance variable to be set to. And then you just do the setting inside of the method. But that doesn't always have to happen, all right? So for set methods, usually we want to pass in a parameter that we want to set the private instance variable to. But let's say you didn't want that. All you wanted was at this point in time, we want that private variable to be like, let's say it's 5, but then at another time, we want it to be 13. And since we already know what those what we want the values to be, we don't need to have a parameter for them. All right, so set methods don't always have to have parameters. So you could just calculate something and set it to one of the private variables. And then as for get methods, you can modify what you would return to the user in the get methods. So instead of just blatantly returning private instance variables, we're going to add some additional information. So let's say we had a private instance variable called name. We had the name, I don't know, Leo, right? Then maybe we could return an array, and then we could maybe return an array that contains information about the name variable. Maybe we could say how many characters my name has, which would be 3. Maybe we can write down what the first letter is for my initials, and then we could put the actual name itself. All right. And accessor and mutator methods are just general concepts that are used pretty often, and it's good to know, and it's good to know how to use it as well. All right, so here's an example. All right. All right, so I'm going to show you guys an example of class methods. So we won't go over the whole code. We'll just go over the get and set methods inside of it. Oh, here it is. Okay, so let's just focus on this class. All right. So, all right. So we have a class called person, and as you can see, we made 4 different instance variables inside of the class person. We have 2 strings called name and email. We have 2 doubles called height and weight. And all of these instance variables are private, which means if you want to access or modify them, we're going to need some get and set methods. Here we have a constructor, right? Hopefully you guys are pretty familiar with this by now. We just set all the instance variables to values that are passed in when the object is created, right? But here are the get and set methods. Okay, so for set, so these 2, okay, I'm so bad. All right, so this is a set method, and it's designed to manipulate the name variable, and this is a get method, and it's designed to get the name variable, I guess. So we have this, right? This means that, okay, this method is public. It's an instance method because there's no static, but the return type is nothing. So not going to return anything. The name is set name. All right. And then from the user, you want to take in a parameter, right? The parameter, whatever the user passes in, is going to be called new name. And then we want to set the private instance variable name to whatever the user passed in. Do you see how that kind of works, right? So that's how a set method works. And then as for the get method, we want to remember to change void to whatever value the return, whatever data type the return type is going to be. So in this case, since name is a string, then it's going to be, the return type is going to be a string. And if name was like something else, maybe it was height or maybe it was weight, then it would just be a double. But anyways, the get methods are pretty simple. We specify the return type, and then we just return the instance variable. All right. And in order to use these, we would create an object of the person class. I don't know. We could just call it show, right? And then when we want to access or modify these private variables, we could just say Joe dot set name, and let's say we want the name to become, I don't know, Bob. All right, and the code just looks like this. And as you can see, when we call the set name method, Bob is going to be the parameter that gets taken in, and then the instance variable name gets set to the parameter we passed in, which means after this code is executed, the name of the object, actually I'll just call it a person. That'll make more sense. Name of the person, instead of being Joe, it will now become Bob. All right. So, and then if we want to access it, let's say just want to print out what the person's name is, put their name of the object, dot, and now we would use the getName method, and that's it. And now here, just like that, we have set or changed the value of a private instance variable, and we have also accessed it. Okay, so that was a pretty good example, I guess, but there's more. All right, so this one is a little more complex, but all right, I'm just gonna delete this, I guess. All right, okay. So here it's similar to what we did before, but the only difference is that we have a little bit more code. All right, so let's go over the get method first. And since email is private, we're gonna need get and stuff methods to use and modify it. And since email is a string, then the return type of its get method is also a string. All right. So this is pretty simple. We're just gonna call this in the main method. We would put the name of the person, get email, and boom, this value is now the person's email. But inside of the set statement, we have a little bit more code to look at. Okay. All right. So let's say we called the set email method inside of the main method. Well, the first thing is that, okay, we're going to need to pass in a parameter, and whatever that parameter is going to be the new email of this person object. All right. And if you guys didn't know this, but in order for an email to be valid, it has to have an @ symbol. All right. This guy, this little thing here, in order for it to be valid. And to check that, to make sure that the email is valid, to make sure that it has the @ character, you have this bit of code here. All right. So the new email that user passes in, we want to figure out the index of the @ variable. Well, this might seem like it doesn't make any sense. Like, why would you need the index of the @ character? Well, fun fact, not fun fact, but like this is actually sort of a clever little trick, because if the @ character exists inside of the new email, let's say, okay, there we go. All right, so let's say the email was this. Well, as you can see, there is no @ inside of it. And if the character that the index of method is trying to find is not there, then it will say -1. So if the index of the @ character is -1, that means we know it doesn't exist, which therefore means it's not the new email that the user passed in is not a valid email. And to tell it to the user, we're going to say, okay, well, this throw new. So this is the syntax for throwing an exception. We say throw new the exception name. In this case, the user passed in an argument, which is this. And unfortunately, it's illegal. It doesn't work. So we're going to use the corresponding exception. I don't want to tell them why they messed up. You say, okay, the new email must have an @ character to be valid. All right. And let's pretend the @ was anywhere inside. Okay, it could be there, whatever, right? Wherever it's located, as long as it has an @ it's valid. So if it has an @ then new_index_of would return a value that is greater than or equal to 0. All right, so let's say it was the first one. Let's say at was the first character, it would be at. Let's say it was the last one, then it would be the length of the string minus 1. But the point is, if at exists inside of the new email, then it's not going to be -1. All right. So hopefully that made sense. But now, pretty simple. I'm just gonna bam. All right. So now we're gonna say, okay, we're gonna now, after all that, after that little check, we're gonna set the email instance variable to the new email parameter that the user passed in. All right, so it's 8 o'clock. So do you think I should go over one more example or go ahead with the rest of the lesson? Wait, Renee, should I like do another example or?
Sorry, you're asking me.
Yeah.
Move on, I'd say, probably. But okay, well,
Almost.
students, do you guys want to do another example? Does this make sense? Give us a, okay.
Oh,
Kevin, do you want to say like what doesn't make sense? Like, is there a particular part that's like confusing?
nice off.
Okay. Then we can try to do, I can work with you later then. Think, does everybody else feel okay so far? Okay, scale of 1 to 5. Okay, one person is saying the bottom part is a bit confusing. Not too sure what the bottom part means though.
Wait, what do you mean by bottom part? Do you mean like this check here? Or do you mean like the other stuff? Or do you mean like the main method? Like, do you understand like the concept of get and set methods and like how to use them? Whoever asked that question.
Okay, they're saying yeah, kind of.
Oh, okay.
Okay, I think, again, you guys need to let us know. I think at this point, we're probably gonna want to finish the information, and next week we'll just be doing a very tight session of going through a lot of information again and like reviewing the particular parts that you guys are having questions on. But you guys need to let us know though, because otherwise, like, I'm starting to compile some things I want to talk about, but you guys need to ask us the questions, please.
Yeah, please. I'm begging you.
Like,
Okay.
I can fit as many people as I can on the Sunday 3:30 help session, but unfortunately I cannot stay for like too long for that one. So the best thing to do is let us know so that we can have something for next week, which is the review week, to help you guys through it. So yeah, think of some questions. Anyways, I think we're gonna go on, but we're gonna spend like the rest of today after we're done with the lesson going through the concepts again. Go on, Leo.
Okay. All right. So wait, what does that mean? All right. So we went over null. We went over get and set method. The final thing, well, not really the final thing, but another thing is how do we compare objects? So I want to ask you guys, but like, you guys don't have to like type a response, but like, how do we compare, let's say, two integers, two double values, two floats, two characters, right? How do we do that? Well, we would, we would use the equal sign, two equal signs placed side by side. But unfortunately, yeah, good job, Kevin. That's right. All right, but unfortunately for objects, that doesn't work. So when you want to compare objects, even classes, you need to use the equals method. when you use the equals method, make sure you put the period in front of the E, like right about there. But yeah. So with objects, the reason why you can't use the normal double equal sign is that it can cause an error, because when you use dot equals, it compares memory addresses instead of the actual value. All right, so when you create an object in Java, well, and like the computer has to allocate memory or storage for that object for future reference. All right, so let's say you put it in like the memory location 2. Then when you want to use that object's attributes, then the computer would go to that memory allocation and get whatever you need. Well, with objects, obviously you can't put too many objects in the same memory allocation. So even if the objects have the same value, since the computer is comparing the memory addresses instead of the actual value, you won't get what you need. So that's why you need to use the dot equals method. So for now, we're only going to be focusing on how to compare strings and other classes that Java has pre-programmed for us. But still good to know. And here's an example. So we have two string variables, S1 and S2. They're both set equal to A. And remember that strings are actually objects. So you can actually use a dot equals method for this. So you would use system.out.println the first object you want to compare, or the name of the first object you want to compare, dot the equals method, and inside of the parentheses for the equals method, you put the second object you want to compare. And since A equals A, that is true, the output would also be true. All right, so here's a little bit more notes, some references. When you say class name A equals new class name, and then whatever arguments you want to pass into the constructor, you are creating a reference to an object value. So every time you create a class, class name isn't actually like the name of the class. It just means any class, I guess. You're actually creating a reference to an object value. And when you say class name B is equal to A, then you're creating another reference to the object value from the A reference. All right. And then references will typically affect what the equals method returns because it relates to memory addresses. All right. It's a little more information on why the equals method doesn't work and why you need to use dot equals. Yeah, so here's an example. All right, so, okay, sure. All right, so as you can see, we have the main method, and then let's look at this for now. We have to create a class called A. We're going to create an instance variable called example, and just to make things easy on us, we're not going to make it private. Yeah, and then public A. Wait a minute. Wait, Renee, why are these all dot equals? Shouldn't they be?
Yes, I changed it from what it was originally. Do you want me to explain it now?
Yeah, sure.
Okay, yes. So this is kind of a relatively new concept that I actually have not been teaching before this. So like, yeah, it's a new concept sort of. And give me a second. I actually do not have this pulled up right now. Yeah, it's something called references, and it's something that's important to know. It's kind of more like the inside information on how Java works, and I think it's important to know. So it doesn't necessarily always have to do specifically with, yeah. So I'm just gonna briefly go over this slide. So yeah, references are essentially when you create something, like we haven't really been referring to it before when we talked about classes in the beginning, but essentially when you're creating a class, right? When you're saying new class name and you're setting it to a class name A, then you're essentially setting a reference. You're creating a reference to a particular object value. In this case, the object value is new class name parentheses. So that's the object value. And when you're setting it when you're having it be set to a class name A, the class name A part is a reference to that particular value. So that's essentially what it looks like on the inside. And I have like a little diagram later for it. But when you're saying class name B equals A, you're creating another reference. In this case, it's class name B to the object value from the A reference, which just means that, yeah, essentially you're creating another reference, like an arrow pointing to the same value. So they're class name A and class name B, they're both referring to the same exact value. And so, yeah, that's kind of an important thing to know, because that means their memory addresses are the same exact thing, because their object values are stored in a particular place. These references are just pointing to that particular value. So that means their memory addresses are the same because the object value is the same. And yeah, this will affect what equals returns because it's related to memory addresses. So when Leo was explaining this, why I used equals was to better explain what happens specifically with equals and why the output is false, true. Because when we look at this, right, like we have class A, we have an integer example. It should be private, isn't it? I know, but oh well. And then we have a constructor that sets the example equal to the A that's passed in. We create A temp 1 equals new A 3, and A temp 2 equals new A 3, and then A temp 3 equals temp 2. What happens is these three print statements return false, true. And the reason, I'm just gonna explain this a bit. So there's a diagram that I want to show to better like demonstrate what references are. And so specifically, okay, so imagine this, right? We're creating different temp variables. Like we have a temp 1, we have a temp 2, and we have a temp 3, right? So we create a box that's temp 1. We create another box that's temp 2 to represent different references and the different variables that we are creating. And then we have a temp 3, right? So what happens is that when we create a temp 1, what we do is we have an arrow that then points to new A3. Okay, so when we're saying A temp 1 equals new temp A, new A3, what we're doing is creating an arrow to this particular value. This is the reference. So like the dark gray boxes, these are the references. And it's pointing to a specific object value. What happens then is that when we create the temp 2, we're creating another different arrow because we're saying new A3 this time for that particular variable as well. Whenever we're saying new, we're creating another different object. Okay, like even if it's the exact same thing, even if this new A3 is the exact same one from temp 1, it does not matter because we're saying new. When we're saying new, we're automatically creating another object value, no matter what is inside of it. So in this case, we're creating another arrow that points to new A3. Okay, and then what happens when we're saying temp 3 now is equal to temp 2? What we're saying is that arrow points to this new A3. The reason for that is because we are not saying new A3 anymore. We're specifically saying this temp 3, we create a new reference named temp 3, and we're pointing to the same object value that temp 2 was pointing to. And so that's why those two arrows are heading to the same exact object value and why temp 1 is over here. Okay, so why that matters to what the output was, if I scroll back through all these transitions, is okay. So when we're talking about equals comparing memory addresses, what we're saying is that we are specifically comparing whether or not these references are pointing to the same exact object value, right? So when we're saying temp 1 equals temp 2, well then, oh, this is a pain. Okay, hopefully you guys can still see even though it's backed up. But okay, so based on that information and based on what I've been saying, so when we're saying temp 1 equals temp 2, based on where these arrows are pointing to for temp 1 and temp 2, what do you think the answer is? Like why? Okay, wait. No, I can't make this. You guys already know the answer. Never mind. But the point is, because these two are different references, right? And they're pointing to different values, then that means the answer is going to be false for equals equals, because of the fact that they're all pointing to different object values, which means their memory addresses are different. Same thing for this one, temp1 equals temp3. Because look, again, this temp1 is pointing to a different object value than temp3 is, right? Temp3 is pointing to a completely different object value, which again means that the memory addresses are not the same. So that means that, again, it's going to return false because they're not pointing to the same thing. Temp3 equals temp2 is true because look, right? So temp2 is pointing to this one. Temp3 is also pointing to this one, which means automatically that they are going to be equal to each other. So that's why it's true. And yeah, it all has to do with the references and what exactly they're pointing to. And the important thing to know is that if they're saying new, then that's creating a new object value, which means that's a completely different memory address. Scale of 1 to 10, does that make sense? And like, again, I did not teach this before, Leo, so you don't have to worry about it, but okay. Thank you. But yeah, let me know, because it's a difficult concept to envision, which is why I had this whole diagram thingy to like better illustrate it. But anyways, you can go, Leo.
All right. Okay.
Actually, I'm thinking, right, there's only 15 minutes left.
You can try to speed run it.
I think that's a good idea. Okay, honestly, okay. Pause for a second, I think. We might have to do the same thing we did last time.